We're going to work with ArcGIS Online as a website where we can make some maps. There are two mapping applications here. The first one is this just make a map is a JavaScript-based tool. The second, ArcGIS Explorer Online, uses the Silverlight plugin in your browser. This is a rich application, and in order to run it, you need to get the Silverlight plugin and make sure it's in there. And if you go to microsoft.com/getsilverlight, you'll be able to check if you have it or to download it and install it right there. It takes just a couple of minutes and it's free. So once you're back at arcgis.com, type in USA Demographics for Schools and search all content. And we'll go to what that looks like. There will be a couple of options there. The original is the one by C. Fitzpatrick. Choose that one. And click the little down arrow by Open. We could open it up inside the ArcGIS.com viewer, but we really want to choose Explorer Online. That's what's going to give us some more capacity. So we open it up, and we begin with a set of data, just like we would in the Explorer in the Make a Map viewer. But here we're going to open up and see the contents, and we see that it's 10 layers of demographic data, and we can turn them on and turn them off at will, make our choices as we go. And each one is going to have a legend that goes with it. Let's go ahead and turn on the legend. And you can see that here we're looking at state data. And it tells you that up in the legend. And if we go and zoom in, and we'll get down into county level, we're working with scale-dependent data layers, so the map legend ties in with what's displaying on the map. And if we just click on Cook County, that's right here in Chicago, slide so that we can see it, we get a set of data that is tied to the layer that we're mapping. And if we turn this layer off, and turn on the next layer, this is population change for the decade 2000 to 2010. Close that window and do an identify again. We get the set of information for that layer. So there are 10 different layers that we can use. And that's what we're going to do here. We're going to look at population change from a low across the country of minus 5.5% per year to a high of 9% change per year as an average through the decade. Let's get some space, and then we're going to work with the query tool. Now the query tool allows us to ask questions across the internet of the data that is stored online. We're going to build a query, hit the plus button to create one, and we need to choose the layer that we're going to work with. It's not pop density, but pop change, and we're going to work with county level data. So we need to click on counties and then click OK. First, let's give it a new name. Let's call this one Pop Change by County, and this is for the decade 2000 to 2010. Now we've got 3 tabs at the top, and the first thing that I want to do is to look at the choices of data that we have. So you can see the counties and their ID codes and the states and a set of numbers for them. And we've got one item that we don't really need here, so let's go into the display fields and turn off the land area and square miles. Now when we go to our query tab, we can choose the number field that we want, and that's the growth rate 2000 to 2010, and we're going to choose a number. Let's see, it's going to be greater or less than. What we want is greater than. This is going to be our low end of our scale. Type in 0 in here, because what we're really going to do is rely on prompting the computer. We're having the computer prompt us for a number. We want the low number in our range, and it goes from -6 to +9. Add, and that's going to be the first part of our query. We'll do the same thing, only now this is going to be less than. Let's again type in 0 here and ask the computer to prompt us. And what we want to do is to put in the high number. So the prompt will be type in high number from -6 to +9. So we've got the 2 parts of our query. Click Add. Here we go. We got 2 parts to the query. And when we click OK, it's going to ask us across the country, give us the counties where the population growth rate is a low of -6 to a high of, let's say, -2. So these are counties that declined the most during that decade. You can see 2 in Alaska, and it looks like 6 in the 48 states. And then we re-execute this, and let's try it again from -6 to -1. This will give us a slightly different number. We'll have a few more counties that have declined, but maybe some not as much as the others. And we could work our way through each of these counties to learn about them. Now let's flip and look at the high end. From 5% annual increase to 9% annual increase on an average. Wow, 15 counties grew that much annually during that decade as an average. Let's see if we can isolate this even further. What about 7 to 9? Go ahead, click OK, and we get one county. And this county is Kendall County in Illinois, and if we zoom to it, we get all the way in and zoom back, and we can see that this is one of the counties outside of the Chicago area. So this querying capability is a very powerful tool, and you can use this with any one of these layers. What we want to do now is shift to the population that is older than 65, or in this case 64 here it says. We're going to add another query. So go to the query window and create a new one, and you can store as many of these as you like. But now we need to choose, it's not pop density, it's not pop change, it's not young population, it's population older than 64, and we want counties again. But in this case, what we really want to do is to focus on one state in particular, and let's choose Florida. So we'll name our query Florida Counties. And that's population change, percent population over 65. And let's go take a look at the data that we have to work with. And we've got a number of fields here, very interesting, and some fields that are going to be less useful for us. So let's go and work in the display fields and figure out which ones we want to turn off for our identify tool. So it looks like these last several we can turn off temporarily. And all this does is just say, don't display these when we do the identify tool. All right, the rest of these we can use. That looks good. Now let's go to our query. We need to focus on Florida, so please, computer, focus your attention on those counties where state abbreviation equals, and we go ahead and type in the abbreviation FL and add. There's the first part of our query. Now we get the numeric part. Population 65 and older is greater than, and it's a rate, so if we just say greater than 0 and prompt us for the value, that will be good. So a number from 0 to the high across the country is 50. So go ahead and click Add here. And now we've got the two parts of our query. Florida counties where the number is what? Well, let's just pick them all. What do we get? 67. Zoom and we can see it. Let's get rid of the layers that we have over here so we get a little space. And now you can see that we've got all 67 counties, and we can work our way through here from county by county. And what you'll see is in the identify window, it's tied in with the map. That's one of those key aspects of GIS. The map and the table are tied together. Let's re-execute this and look for higher percentage. How about 20%? Let's go with 20. Click OK. And we get a nice ring in southern Florida. Let's try this again. Let's go for 30% of the county is over 65. Wow. We've got 6 counties now. So let's go in and see. We can look at this one by one, 34.7. And so we can work our way through these counties and find the ones that are the highs and the lows. And wow, there's 37%. That is, looks like that's going to be probably the highest one of these. Pretty big. Okay, so this querying capacity in conjunction with the mapping and analysis tools that you have from symbolization and classification, this is really what GIS is all about. And if we zoom all the way out, we can ask an endless number of queries at the state level, county level, census tract level, block group level, just using this particular data set. There's a lot of data to work with, and there's an enormous capacity with GIS here.